So next up, we have Mr. Jake Archibald, who you met before. Jake is a longtime front-end developer. He originally worked on the Glow library at the BBC. It was kind of like a competitor to jQuery, kind of, sort of back then. Because they needed IE 5.5 support, is that the reason?
And 5.
Yeah, and 5. IE 5 support, yeah. This was good. He also is an expert at FontFace. He made a fantastic offline tool for creating CSS sprites called SpriteCow. He developed a technique for including IE-specific styles with Sass called Sass IE, naturally. More recently, you might know him from his work with the ApplicationCache, where he wrote a number of articles and talks. And today he's going to be telling you a little bit more about ServiceWorker. So, Jake Archibald.
Hey. So couldn't help notice that in Matt's list of talks there that you should pay attention to, mine wasn't on there. So no Christmas card for you this year, okay? So making stuff work offline used to be very easy, right? I mean, it's only really become an issue since the advent of the internet. Before that, you had everything you needed in front of you. You had the machine that was going to do 100% of the processing, and you had the thing that was going to be processed. And this is the first computer I ever owned, and we should have audio here. Oh, we do a little bit. And these were the sights and sounds you would get just to do something like render a simple image on the page. I got this working on a Spectrum emulator last week, and it's like the most fun I'd had in ages. And I uploaded it to YouTube, the full video, and someone actually took the audio, recorded it onto a cassette, and played it in a real ZX Spectrum, and it worked. Well, it crashed at the very end, but for me, that makes it more authentic. It was great. But in these days, the only thing you needed from outside the building was electricity. And that came from beyond the wall, wherever it comes from. But as long as that stream was constant, then you were gold. Everything would work. But then we got another stream. We got another stream from beyond the wall, the internet, data on demand. It looks like people were terrified of it at first, but not anymore. In fact, now, even things that are kind of built around physical media, they can't resist a delicious slurp of internet before they'll do anything. I didn't buy new games for the PS3 because you would go through this kind of couple of months where every time you would try and play the game, it wanted to connect to the internet and download like a 50 megabyte update. And I just wanted to play a game. And they do automatic updates now, about time really, because I just want to play a game. I've got the disc here in my hand. These days, most devices will ship with a cache for electricity, which can be used when the stream isn't available, and we call it a battery. In fact, as we've become less reliant on this electricity stream, we've become more reliant on the internet stream, especially on the web. I became very aware of this back when I worked at a small agency. So one day, I needed to go to the toilet, and there were 5 cubicles for me to choose from. But unfortunately, on this instance, the first 4 were occupied. And that's usually OK. I tend to only need 1 toilet per visit. But I knew from previous experience that the office Wi-Fi only extended to the first floor. And there's no mobile data in there either. And I thought for a moment, and I was like, no, I don't consider this good enough anymore. As a human being, it's my right to have internet when I go to the toilet. I've been using this joke for a while now, but it comes with an important update. In the Google offices, or certainly in the UK, the situation is much worse. We have no data at all, completely dataless, to the point where saying, I'm just going offline, has become a kind of euphemism. Of course, there are other places without internet, like large parts of my daily commute, because I get the train in through the countryside, and underground systems, of course, planes, international roaming. You have data, but it's too expensive to use. Have we lost something through this data dependency? Wouldn't it be great if things like Wikipedia, Google Maps, and YouTube were once again resilient to fluctuations in connectivity? Well, as a community, we thought so, and we asked for a solution, and thus we received the ApplicationCache. How did that turn out? I have voiced my opinions on AppCache before, but today I would like to defer to the philosopher Andre the Giant from then WWF, who said this: I don't like to speak badly of people. I have grown up thinking and being told that if you cannot say something nice about someone, you should not say anything at all. Yeah. Oh, but I must break that rule in this case because I hate Hulk Hogan very much. He is a big ugly goon and I want to squash his face. Yeah. AppCache needs squashed in the face. The problem with AppCache is it's like this. It looks so simple, so invited, so easy to get started. But it comes with an instruction manual. And it's huge. And if you don't read it all and remember it all, you will be caught out. If I make an HTML page and point it at a manifest like this and list some files in it, they'll be cached and they'll work offline, and that's great. But any page that points at the manifest, such as index.html here, that will automatically become part of the cache. And that counts per URL. So if the URL just has a change in the query string, that's a new thing that will be automatically cached. And this will just build up and up and up. There's no way you can prevent it, and there's nothing you can do to clear it out once it happens. Also, so in a page like this, the CSS is going to work. That should be, it shouldn't be SCSS, should it? What am I doing? Anyway, the JavaScript will work. But what about this? This won't load, even if you're online, because it's not in the cache. And AppCache won't let network requests through by default unless you add this little bit of magic at the bottom. Of course, this is all in the manual. But there's nothing in the manifest there that hints to me that this is the behavior, this is what I should expect. I was on a transatlantic flight, and I had nothing better to do. I was offline. So I tried to draw how AppCache works. And it took me like 8 hours, partly because the specification is so dense and it kept confounding my expectations, but also because the person in front had fully reclined, so I was having to use my laptop like a T-Rex. But it's that complicated. And there's nothing wrong with high-level APIs, right? I mean, look at jQuery. They looked at what people were doing with the DOM, all of the common stuff, and they made shortcuts. Some quite overloaded methods. You need to know what the different arguments actually do. But it works in practice. They're really nice shortcuts. However, AppCache tried to be the shortcut before it knew the long cuts. And it looked really sweet on paper. But when developers actually looked closely at it, we were like, oh, no, don't like the look of that. Take that away. So we're going to give it another try. We're giving it another try. And the new thing is the ServiceWorker. Actually, I think this is the first talk on it, so that didn't feel like a deserving introduction. So we'll give that another go. And the new thing is the ServiceWorker. But yeah, the current status is it's a specification that we're developing and drafting on GitHub. We've been working on this a while, along with Mozilla and other third parties who are interested. And we've been prototyping bits and pieces in the browser. But the spec is still a work in progress. I'm going to show you bits of it. And any feedback you have on it, anything you see you don't like, you can talk to me. You can ask me in the Q&A. But you can also file issues on GitHub. There's nothing to play with in the browser yet, but we're hoping to hit Canary sometime early next year. So what is a ServiceWorker? Well, it's a JavaScript context that operates for a set of URLs, and you can use it to manage behaviors. And it's actually kind of easier to show you rather than describe it. So on just a normal page, you would register a ServiceWorker like this. The first argument, you're telling it which URLs you want it to be in charge of. The second argument, the URL to the JavaScript file that's going to do all the controlling. And congratulations, you now have a ServiceWorker. And the ServiceWorker is very similar to a shared worker, meaning it exists separately to the pages, and multiple pages can communicate with the same instance of the ServiceWorker. If you've developed Chrome apps before, this is kind of similar to the background pages model. But these are much lighter. They don't have a document. They've got no DOM. They're less of a memory burden and less startup cost than a whole page would be. So our ServiceWorker file currently looks like this. It's empty. And how does that affect the behavior of pages? Well, it doesn't. Magic was this huge problem with AppCache. An empty AppCache file would start doing things. This doesn't. ServiceWorker aims to have as little magic as possible. It's a bring your own magic API. You can make your own magic with it, but by default, it doesn't do anything you don't expect. You're in full control. But what control do you actually get? Well, you can listen in on network requests. You get this event. So I'm just listening to the event using the old DOM method, but you can use add event listener if you want as well. So here, if I navigate to /foobar, I'm going to get a console log for that in this other JavaScript file. But I'll also get one for any requests that are triggered by that page as well. Even if they're to another domain, the usual cross-origin rules apply when it comes to accessing data, but you'll still get the event for the request actually happening. Anyway, so what? Well, like other events we have in the browser, you can prevent the default, and you can do something else. So here I'm looking at the request URL, and I'm looking to see if it ends with one of the image extensions. And then I'm going to call event.respondWith. And event.respondWith takes a response object, which is new in ServiceWorker, or it will take a promise, which will eventually resolve to a response. And the fetch method, which is also new in ServiceWorker, is going to give you a promise to a response, a promise for a response to the URL you give it. So here I'm just redirecting all of the requests, or I'm going to serve up this not a cat image instead of any other images on the page. So note here I'm actually satisfying a cross-origin request with a same origin response. And you can do the opposite as well. Security is always determined by the origin of the response, not the request. This isn't an HTTP redirect. You're just serving up a different file. The browser, as far as the browser is concerned, it requested probably cats again, and it got it. But you could do an HTTP redirect if you want. In fact, you can create any kind of response. We have a kind of low-level API for that. So new, same origin response, give it a content type, give it a body, and I'm going to serve that up. And you can see how you could start to make things work offline with this. I could get a template from the file system API. I could get some data from index database and mush them together and serve that out. But that would be a lot of code, and it would involve some pretty gnarly APIs. So we're introducing a new storage system specifically for this, and it's the cache list. So we just looked at onFetch, but there are other events as well. OnInstall. So this is called when the browser sees the service worker for the first time, and it's your opportunity to get everything ready before you start hearing about requests, before you start handling requests. So in here, I can create a new cache, give it a set of URLs, and add it onto the caches object. And these are just URLs. They can be from another domain. That's fine. And they'll be downloaded, and we add them to this cache called static v1 or whatever. Now, the cache won't serve responses until all of those files have successfully downloaded. And if one of them fails, then you get nothing for that whole cache. This is a good way to group files together that are dependent on each other. So if you can get the network failed.html file out of the cache, you can rely, the PNG is there, the JS is there, the CSS is definitely there. They're dependent on each other. We're creating one cache here, but you could create many. Like for a game, you could create a cache per level. For instance, for a newspaper, you could do a cache per issue or a cache per article. And then we wait on the cache. So event.waitUntil takes a promise, and this is where you can say, look, I'm not actually ready to handle requests until this stuff has happened. And on cache objects, you get this ready method, which will resolve once that cache is successfully formed. You might wait on all of your caches, or you might only wait on some. So in the game model, you might only wait on level 1 and allow the other levels to download in the background, and you'll just handle it if level 2 is not there for whatever reason. For instance, you could let if the user goes offline while they're still downloading levels 2 and 3, you can still offer an offline experience for level 1, and then when the user gets to the end of level 1, you can say, look, we don't have the files for level 2. We'll save your position, and when you're next online, we can pick up where we left off. But we're just creating caches here. We're not actually using them. To use them, we go back to our onFetch method. And once again, the respondWith method, and I'm just going to ask the caches for a match for this URL. I can be specific and say, look, I only want to get a match from the cache named static v1 or whatever. But we don't really need to do that here. We don't need to be that specific. Of course, if that doesn't match anything in our caches, because we're handling all requests at the moment, we're going to get a hard failure, even if the user's online, because we're saying go to the cache for everything. But this whole thing is promise-based, like the promises that we now have in the DOM and JavaScript. So we can fix that just by adding .catch to the end and do something else. If you're unfamiliar with how promises work, then there is an HTML5 Rocks article coming, should be out next month, that hopefully will explain it. But all async success failure methods in JavaScript and the DOM are moving to this model. So if we fail to get stuff from the cache, it's going to, for whatever reason, like something fails or there's not something in the cache for that URL, we fall down to this next step. And what I'm doing is I'm using fetch, and I'm just going to pipe through the request. So we're going to go to the network. Of course, if there's nothing in the cache and the network request fails, we're going to get nothing. But we can fix that as well. We can catch again. And here I'm going to go to the cache again, and I'm going to get the network failed.html file and serve that. And I know that's there because I depended on it in the onInstall method event even. And our error page is going to be better than the browser's default one, because we can say, hey, I'm afraid that resource is not available, but here's a list of things which are. Here's the articles that are available to you. Here's the levels which will work. As I mentioned before, onFetch doesn't just fire for full-page navigations. It also fires for assets on the page, your JavaScript, XHR, CSS, images, etc. we can differentiate between the two using event.type. Because it makes sense here. We don't want to serve up network failed.html for an XHR request. That doesn't work. So here we can just serve it up for full page navigations. So this bit of code, what does this look like in AppCache? It's a lot simpler. But it's not actually simpler, is it? It's just less characters. This doesn't tell me that for any URL, it should go to the cache first, and then try the network, and then fall back to network failed.html. And this is just one of the few cases that AppCache can actually do without too much issue. But you don't get the full separation of caching and routing, and you're going to get the weird auto-caching of all pages that link to it. And if you wanted to serve a different fallback for XHR compared to like navigations, AppCache can't do that. If the worker code, starts doing something I don't understand, what can I do? I can add a console.log. I can add a JavaScript breakpoint, and I can step through it step by step and look at all the values of like variables, look at the whole state on every step. If this does something I don't expect, and it will, we're back to the manual. Read the whole thing again. When I was building Lanyard's offline-enabled mobile site, I found that some devices were behaving differently when they were offline, when they were out of signal, to when they were in flight mode. And what I was most interested in is doing a proper no reception test. About how could I test genuinely no reception? This is before I worked at Google, so I couldn't just pop along to Faraday's lavatory and sit there testing phones. So I populated the caches on each device, and I went to the local underground station, because there's no mobile reception down there. And I tested each device, see what it did, and I was filming it with a digital camera so I could review it later on. And I looked up and I saw that 2 police officers were kind of standing in front of me, pulling faces and pointing behind me. And I looked around and I was sitting in between 2 posters. One said, "Someone's got more than one mobile phone, probably a terrorist." "Doing something odd with a camera, probably a terrorist." I was ticking all of the terror boxes. Thankfully, the police thought this was hilarious and decided not to shoot me to pieces, which was very nice of them. So the ServiceWorker lets us build these offline experiences in a flexible and testable way. But who cares? I mean, we've got train journeys, plane journeys, roaming abroad, but mobile coverage is just getting better and better. Planes and trains are getting Wi-Fi, some even for free. Mobile providers are starting to, remove roaming costs. Maybe even one day, Google will put a Wi-Fi antenna outside the toilets. Is this problem going away, this problem of zero connectivity? When I first started making stuff work offline, my instinct was to build things as normal and then catch the users that were offline. And you can do that in ServiceWorker, because you do what you want. I could do onFetch, event respond with, go to the network, and then catch that and do something else, like pull some data out of the cache. So the people who have network connectivity are going to get fresh data every time. Users without connectivity are rescued. We can give them something. This is graceful degradation. And as we found with graceful degradation, it's the wrong way around. You see, when I want to get something from the internet, I have to wake up the radio or the Wi-Fi device. And on 3G, that can take a couple of seconds. And then we can begin the epic journey to get data from somewhere else in the world. And it's a dangerous business going out onto the internet. We need to negotiate the router, ISP, DNS, intermediate proxies, the destination server, grab what we need, and then come back through all those things. It's a lot to do. And if any of these things is busy or flaky, we're going to be slow. Or worse, we're going to end up with a total failure. But we don't know it's going to be fast or slow until we try. We don't know it's going to succeed or fail until one of those 2 things happens. And this epic journey is per request, and your pages are made out of many. This is why I like progressive enhancement, because you can get stuff on the screen with less requirements from the network. You just after the HTML, a bit of the HTML and the CSS comes down, you can start rendering. But ultimately, it's still network dependent. And when your phone's like this, it's like a one-legged dog. It thinks it can still play fetch, but it can't. And boy, will it try. And you have to sit there watching it drag itself along the floor with its one leg. And it's heartbreaking. It'll spend minutes trying before it gives up. But even if your connection's like this, you're still at the mercy of everything else out on the internet, any problems that are there. And if you've got something already on the device, if you already have an offline experience, why wait for the network to show it? You don't have to leave the device to get to first render. We should build our pages offline first. The next generation of progressive enhancement treats the network as a potential enhancement, an enhancement that might not be available. So sure, connectivity is getting better, but it's very rarely going to be faster than getting stuff straight off the device. This whole thing is as much about improving performance for users with connectivity as it is for giving something to those without. The Hoodie guys made a great post about this, which I recommend reading. But these ideas are pretty new to the web, but some native apps have been doing this for quite a while. Here we can compare the loading of the Google Plus mobile site versus the native app over a pretty decent mobile connection. Unfortunately, we have to give the website a head start in this because it has one of these. I love the web. I hate this. You know, we should not be doing this. But we'll gloss over that. Yeah, thanks. But we're going to load the main site now at the same time as the app. So we go, and the native app has content on the screen. There it goes, and the website's still thinking about it. Oh, and now it's being blocked by a font download, and eventually it comes through. If we ignore the font delay, then both the app and the website actually got fresh content around about the same time. But before that, the native app shows cached content, and it feels so much faster by it. It looks like it beats the website by 2 seconds. And in this example, connectivity was good, and the mobile site got an advantage because by going through the slam door thing, we did a lot of the DNS work up front, and we did a lot of the we had some warm-up of the connections and the radio. As connectivity gets worse, the app is going to look better and better compared to the website because it can just render straight from the device. ServiceWorker levels this playing field. So we can start by just serving a page shell from the ServiceWorker. Just the UI, but no content there. And then we can start up a spinner, and we can see if we've got any cached content. And if we do, we can show it, and then start going and fetching some network content. If we don't have cached content, that's fine. We'll just go to the network and see if we can get something from there. And once that works, we can show the new content and hide the spinner. If the network request fails and we didn't show any cached content, then that's a shame. We have to show an error message. But if we did show cached content and the network request fails, we can actually fail silently. Because this is just a load of a page, the user hasn't hit the refresh button specifically. This is the offline experience, and it works. And this is what a lot of native apps do. We can represent that diagram with promises. And once again, if promises make your eyes bleed, then keep an eye on HTML5 Rocks next month. Hopefully there'll be an explanation of it. But actually, we can do better than the flowchart because we can make the network request at the same time as we make the cache request. Because why wait on the cache before we actually try going to the network? It is possible in extreme cases that the network request will beat the cache, like if the user's hard drive is made of old cassette tape, but their internet connection is amazing. It is possible. We can let the two requests race. But we've got these two methods where we go and fetch data. And in one, we're asking it to go to the cache, and in the other, we're not. How does the page tell the service worker where to get the data from? Well, here's our implementation of fetch data. It's just XHR. It's pretty simple. If options object.useCache is true, if there's no service worker there, we're just going to reject at this point because we can't do anything about it. But if the service worker is there, we can set a header. We're going to set in header x useCache to be true. And then just serve up the XHR. I'm kind of pretending that XHR uses promises, which it doesn't at the moment. Hopefully one day it will. This header thing looks a little bit magic, and it is. But it's not magic in the service worker. It's magic you can bring as a developer. You see, over in the worker, we're listening for requests, and if it's to the API, we can look for that header. And if that header's there, we can just go straight to the cache, and only from the cache. And if it's not there, well, we can get rid of that header and just go to the network, because we don't want that header hitting the network particularly. It's not useful. But at the same time, we can update the cache with the response we get back. The important thing about the code here is it doesn't make any assumptions about the network at all. It just tries stuff and sees what happens. It's reactive, not predictive, because predictive doesn't work. Case in point, navigator.online. Aside from having the worst camel casing since XML HTTP request, it's useless. If you have no Wi-Fi reception and no other data, navigator.online is going to be false. Great. If you have some Wi-Fi, it will be true. Even if the router you're connected to is ultimately plugged into some soil, it will be true. Predictive doesn't work. Navigator.online doesn't know anything outside the device. It only knows about the first hop. It doesn't know it doesn't know if the rest of the network has just like soiled itself. It can't predict that sort of thing. Instead, just try making requests and react to what happens. So I've got a couple of minutes left of the talk. It's quite short, but I wanted to throw together some other API examples, some stuff that I haven't covered so far. If you've got a service worker and looking like this, you're caching some stuff, at some point you'll want to change that. You want to change the URLs that are in there, maybe change the routing, fix some bugs, add some new routes, whatever. Well, the browser is going to check for updates to your service worker file, serviceworker.js. It's going to check for updates on every page navigation. You can make this not happen with HTTP headers if you want, but by default, every page navigation. So just change stuff. I'm going to change the URLs. I'm going to use cache static-v2. That's fine. And the browser will pick up the byte differences in the file and go, oh, this is a new version of the service worker. Excellent. So it's going to fire on install for that new service worker, but the old one is going to remain running, handling requests and pages that are active, that are actually using it. And that's why we create static v2 rather than mess around with static v1, because there are pages still using the old version. This new worker won't take over dealing with pages until the static cache is ready, because we've asked it to do that. But also it waits for all pages using the old version to go away. And this is important because it means that you won't end up with a situation where you've made some changes to your database, but there are still some pages trying to use the old model, the old pattern. And worse, they're saving stuff that's not going to be picked up by the new version. Of course, you can override this, like most things. You could, when you're ready, when your static cache is ready, you can call event.replace. And this is saying, look, I don't care. I am ready to go right now. Kick the other worker out. I'm going to take over those pages. I mean, that means you're going to be taking over pages that were loaded using old stuff from the cache. But if you can deal with that, that's fine. You can take over straight away. Another method can smooth this transition, reload all. What this is going to tell, it's going to tell all the pages that are currently active to unload. And when they're all unloaded, the new worker will step in and those pages will reload. But each page gets the opportunity to cancel this. So if in one of the pages the user's halfway through writing a comment or an email, it can go, nope, I'm not ready. I'm going to cancel this, and I'm going to let you know when I'm done, and we can continue upgrading. You get an event when you're ready to take over on activate. And this is the point where you'll go and delete the old caches because you don't need them anymore. The old worker's gone. You can do your IDB schema migrations or whatever. You rearrange file systems and so on. So this is us controlling the cache by changing a list of files. But you can let users control the cache themselves by deferring that to them. So you might have a page with like a read later button. And when it's clicked, you can post message to the service worker. Telling it, we want to cache the ID, the article with this ID. And then over in the service worker, you can pick that up and go, oh, is this a post request for read later? Cool, I'm going to go and find whatever URLs I need for that article just using XHR or something. And when I've got those, I'm going to add them all. I'm going to create a new cache for them. And I'm going to return when that's ready. And then I'm going to post message back to the page to say, yes, that thing is now available offline. And this is how you would do something like a read later button. It gives you full independent control of caching and routing. So this is something that isn't in the spec yet, but I just wanted to show that we were thinking about it. With your caches, they're static, but we want you to be able to make a cache, and that updates in the background. We don't know the API yet, but just something like auto-update is true. And this means that the browser can update that cache in the background, even when the browser's not open on the phone. It can just be periodically checking this stuff for updates. The frequency it would do this would depend on how often the user uses your site, which is the iOS model, which works pretty well. So yeah, it all works in the background service. It's really nice. Developing for the web has huge advantages. If a thing has a screen, it's more and more likely to have a browser on it, right? Most devices now have a browser on. When someone goes down the native path and develops multiple versions of the same thing for different languages, as a platform, we must ask why and fix that bug because it is a bug. The service worker is one of those fixes, as are many of the things that are going to be covered over the next 2 days. Service worker lets you get content on the screen seconds faster. You can use it to ride smoothly over bumps and jams in the network. And it provides the groundwork for other things like background syncing, alarms, push notifications. We're looking at putting all of these things into this model. And I don't know, you can probably tell from how I'm speaking about it. I'm really excited about this, and we hope you are too. Thank you very much. Cheers.